Let's learn about the rest of the language. To match individual characters, you just write the character. A single character matches itself in a string. So the regular expression B matches the string B. A sequence of characters in a regular expression matches that same sequence in a string. So if I write B followed by E followed by R, etc., that would match the string Berkeley, and it would not match anything else. Here are all the special characters. By the end of this video, you'll have seen them all used. But if you want to actually match these, then you have to escape them by placing a backslash before it. So if I want to match an emoji that looks like this, I would need to escape the parenthesis, since it's a special character, escape the backslash, since it's a special character, escape the dot, underscore is normal, here's another dot, forward slash is normal, and here's another escaped parenthesis. This is certainly the ugliest part of the regular expression language, is how to deal with the fact that you might actually want to match special characters. So now you've seen the downside of special characters, let's look at the upside. You can use them to describe character categories. The reason dot is special is that it matches any character. So the regular expression .a dot matches any 3-character string that has an A in the middle, like Cal or Ha, or A with parentheses around it. If you actually want to just match a dot, you need to escape it. But if you want to match anything, then you just put it in there. And isn't it convenient that it looks like a little placeholder? If you'd like to constrain what can be matched, not just to any character, but to letters, numbers, or underscores, you use \W. So this would not match Ha exclamation point, but would match 3 a.m. or Dad. \D describes a digit. \S describes any white space character, including a space, or a tab, or a new line. It doesn't match 2 spaces in a row. You'd need to write /s/s to match that, but it will match any kind of white space. And then the most flexible thing is to enclose some list of options or ranges in square brackets. So this is just 3 characters long, B followed by some vowel followed by D, and this would match any of these 5 words. Within square brackets, you can write individual letters like we did here. You can write ranges, and you can also write /D or /W. So this says, take any letter from A to S, or any digit, and match one or more of those. So C is in the range A to S. The range is inclusive, and that matches CS61A. We've talked about individual characters, but then there are groups. Groups have several purposes. They correspond to substrings of the string that matches the full pattern. And then anytime you match the whole pattern, you also match each group to a substring. So if I write down the regular expression fall 20 something something, not only does this whole pattern match fall 2021, but a group matches the 21, and that would allow me to figure out which particular year is described within this match. The vertical pipe character matches either of 2 sequences, so I could match either fall 2021 or spring 2021 by writing fall or spring. You can have arbitrary regular expressions on either side, including square brackets and dots and all of that. And a whole group can be repeated multiple times. So this regular expression says, I want an L followed by 1 or more OLs. But the whole group needs to be repeated, so you can get lol or lol or etc., but you can't have lo. It has to be OL, and there's no L at the end. Now on to quantifiers, like plus. A quantifier expression applies to the previous group or the previous character if there is no group. So for example, if I have a description of a character, which is either O or L, and then I quantify it by saying 1 or more of those, that matches 1 of those 2, or 3 of those, or 1, 2, 3, 4 of those, or 1, 2, 3, 4, 5 of those, and each of those is either an O or an L. That's not the only kind of quantification. Plus says 1 or more copies. Star means 0 or more copies. So this is B, any lowercase letter, followed by Y, which matches any of these words. A question mark is 0 or 1 copy, so the colon matches a colon. This square bracketed expression says either a dash or an O, and the question mark says you can have either of those or none of them. Then the backslash parenthesis gives you a close parenthesis, which would match 3 different smileys, one of which has no nose at all. And finally, curly braces tell you a particular number of copies. If you have 2 numbers, then you go from this minimum to this maximum. If there's only 1 number in the range, then it is both the minimum and maximum. So this says a B followed by exactly 2 copies of a group that starts with E and then has 2 more characters, B-E-R-K, E-L-E, and finally followed by a Y. There is one more detail. I know this is a lot, but it's worth mentioning this because it's used so often. A common application of regular expressions is to search for a pattern within a much longer string, and anchors describe the context within a longer string in which a pattern is allowed to appear. So everything we've done up to this point talks about the contents of the string that matches the pattern, but anchors talk about the context. For example, if we have a long string, tell Oski that he lost his hat, anchors, the caret and the $, correspond to the start and end of the string that we're matching with the pattern. So a pattern start of the whole string, and then 1 or more letters or numbers would match tell because tell comes at the beginning. But it wouldn't match Oski because Oski doesn't come at the beginning. The $, says that what is matched has to be at the end. This matches AT, but wouldn't match the ST because it's not at the end of the whole string. And finally, the \B anchor corresponds to the beginning or end of a word. So if I say I want some character and then an S, and that needs to be at the end of a word, that would find IS, end of word, but not OS because there's no end there. And that's it. There are a few more details that we have not covered, but I think this subset really gives you the productive core of writing a regular expression. And now it's time to turn into how to use them within the context of a larger program.